in talking about astronomy and mapping the sky, one of the things we need to talk about is magnitudes. And so the magnitude is going to be the how bright a star appears in the sky. So you look at a bunch of stars in the sky and you say, wait a minute, it's real clear that they're not all identical. That some of these stars are brighter stars and some are dimmer stars. And so how do you rate them? So one of the earliest star catalogs was done actually by a fellow by Hipparchus of Nicaea. And what he wanted to do was categorize the stars and kind of make a list of them in order of what he considered their importance. Well, the importance of the star was very much to him related to the brightness of the star. So the brighter the star, then the more important it was. So he grouped stars by, so he's grouping them by importance. And so how does he do that? Well, what he essentially does is he takes the stars and he breaks them up into a variety of categories. Okay, and the categories he calls 1, 2, 3, 4, 5. Well, later they added 6. Okay, and so he says the number 1 stars, these are the most important, and those are the least important. And so this became known as the magnitude of the star. So the first magnitude stars, magnitude 1 is brighter than magnitude 2, which is brighter than magnitude 3. Magnitude 6 is roughly the dimmest you can see with the naked eye. And so that's the magnitude scale. Okay, now later they realized, well, it's not all this easy, because there's some stars even brighter than that, so that's 0, and there's some even brighter, that's going to be -1, or even -2 would be the brightest star you can see with the naked eye. And then they realized, well, planets are even brighter, so that's even more negative. And when they had optical instruments like binoculars or telescopes, you could see dimmer stars like that. Then they started realizing it's even more complicated than that, and you can divide this thing up even more. So not all second magnitude are equal, not all third magnitude are equal. So we have like magnitude 2.5, 2.6, so forth, down to 3, 3.1, etc. So now we can divide this all up and break it down into the individual sort of magnitudes that we talk about. Now, this is confusing to students, because I would say, hey, there's an asteroid, and this asteroid is like magnitude 6, and that other asteroid is magnitude 8. Well, students like to think the magnitude 8 is brighter. Well, no, the bigger the number, the dimmer it is. So bigger number is dimmer, smaller number is brighter. So big number is dim, and small number is bright. Okay. So the sun is close to magnitude -27. Okay. The full moon is close to magnitude -13. Venus can get up to over magnitude, brighter than magnitude -4. Sirius, depending on how you measure it, is magnitude -1.5 or magnitude -2. There's different ways of measuring the magnitude. There's magnitude as your eye sees it, or magnitude as the camera sees it. So there's different ways of measuring it. Roughly, rule of thumb, the dimmest that you can see is magnitude 6. So this is the limit. So if it's brighter than magnitude 6, so smaller number than 6, you can see it. If it's bigger number than 6, you cannot see it. Binoculars get down to about magnitude 10. Hubble telescope, is even better. It gets magnitude 30. Well, actually, it's gotten even better than that. The Hubble telescope once was looking in one part of the sky for a 2-week time exposure, and it was able to see things much dimmer than magnitude 30. The longer a telescope looks at something, the dimmer it can see. So magnitudes are our first sort of foray into mapping stars, because it is a way of designating how important a star would be. Now, on your star maps or the planisphere that you're using for your class, you'll notice not all the stars are the same size dot. So the idea is the smaller the magnitude, that means the brighter the star, the bigger the dot. The bigger the magnitude, the dimmer the star, the smaller the dot. And so that's kind of how most star charts tend to display this. The size of the dot is symbolic of how bright the star is. So the bigger the dot, the brighter the star. The dimmer the dot, the smaller the dot, the dimmer the star.